We got these lines. There, I got rid of those lines. I had to tap the screen. By tapping the screen, I get rid of those lines. Yay, we're learning stuff all the time. So this is the tree diagram just for this video, I'm just saying. It's on page 675, and it's number 4, right? Okay, so we're going to go here, and this is correct. So it would be 0.5, and this would be, oh shoot, I have a piece of paper underneath it or something. Okay. Okay. And I hope mine turns out for me. Okay, so after the first trial, you have 2 ways, correct or wrong. Okay? Now the next one, we have C, and we have wrong. Hi, Max. And we have C. He tries to sneak in here. And we have W. Look at after the second. We have 4 choices. Okay? So now I'm going to go to the third, I guess, guess. And you have this. Now this is where I'm getting kind of... And you would have C, and you have W. And you have C, and you have W. And you have C, and you have W. Notice I have 8. Now the last one, I might get there okay. You have C, you have W. Uh-oh. You have C, you have W. This is where it gets squishy. You have C, you have W. C is for correct. Oh, I'm getting better at this. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I did miss one.
C in the middle.
And that's, oh, dang. Okay, so how am I going to do this? This is W, this is C. Where it gets really squishy. Darn. Thank you. So this here, remember this is all 0.5s. Everything is 0.5 because it's either right or wrong. There wasn't any probability of anything else. So for C, 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 this is 0.5 to the 4th. Okay? How do I know when to stop? Did he come in late? You came in late. We already talked about that. So, can anyone explain it to him? How do I know to stop there and not keep going? Abraham, you can tell him. Why is it 2 to the 4th? You had 4 guesses. So you know to stop when you have 16 down here. You've done 4 guesses. Here's a guess. This right here, whoa. This right here is a guess. This right here is a guess. This right here is a guess. And here's one. So you have 4. Okay, so now you would go through, you'd have C, 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 W. You'd have C, C, if you follow the route, C, C, W, C. You'd have C, C, whoopsie, C, C, W, W. And you're going to get, what you're actually making up is the sample space. Get out of town with that one. So, are you impressed? This is our statistics teacher here. Okay, so we have W, C, C, C. We have, I don't like tree diagrams, Miss Shea. W, C, C, W.
Well, that's why you don't like that.
W, C, C, C. It's TD. Well, it's also artistic, and you're probably really good at that because she's really good at art. Okay, so you have this. And you have W, C, W. Okay, W, do you see how I'm following every path? And I have W, W, C, C, W, W, C, W, 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 C, C, and W, W, C, W. Now, back in the day, you guys used to make up sample spaces, like of true-false questions. And you'd go through and you'd make up all the different ways a true-false can land in the 4 blanks. This is exactly what you have done in a tree diagram. Okay? So on all of this, you would have this going about this method. So if I want 4 correct in 4 guesses, it would be right here. Yes?
What is that W go to CC?
What are you talking about? What W? There's a million W's. This one?
Yeah, no, second one. Yeah.
It goes to W, WCC.
Wait, why is it WC? Why is it CC?
Because it goes from W to CC.
It goes WWCC. That's that one.
You see how it's
Look
right there?
at the W, it's good.
WWCW.
And then look at the bottom.
Oh, they're saying it splits to both correct. And if you go down, it also splits to correct instead of a W. The last one.
Oh,
should
I
be-
gotcha.
yeah.
Okay. Okay. Boo boo. Boo boo. Okay, so I want 4 correct in 4 guesses. So that would be 4 correct in 4 guesses. And there's only one of them. Okay? And so you would figure that out, and it's 0.0625. Now, how does that work with our formula of binomial distribution? It is the combination of the number of things to the number of successes, and P to the number of successes, and Q to the number of failures. The binomial distribution is dealing with something that is success and fail. So this is what it's talking about. So here I have 4 guesses, or 4 guesses. I want 4 correct. That's success. Correct is success. I have, this is 0.5. How many successes did I have? 4. And I'd have 0.5 to the 4 minus 4. So I'd get 1. I'd get the same answer by using the formula. Okay? So now that we're on that, what other question do you have on this page? I'd like to do one more, believe it or not. I'm so excited about all this. Okay, so I'm going to just do one. 15 or 17. Okay, what'd you say? 16? No, I'm going to do 16 and then I'll do 17 because I'm going to show you a shortcut. Kenya, you got to listen. Okay, so on this one, we have a fruit company guarantees that 90% of the apple it ships will be ripe within 4 days. Find each probability for a case containing 12 pineapples. So on 16, at least 10 are ripe. So we'd have 10, 11, or 12. We're going to have 3 cases, right? So we are taking the probability of at least 10 are ripe. And then we've got to get to the lesson. Okay, so we're going to take the probability that 10 are ripe, the probability that 11 are ripe, plus the probability that 12 are ripe. Okay, and then I'm going to teach you something on 17 that you haven't been taught, so ha ha ha. So we have 10 pineapples, or we have 12 pineapples. Oh, sure. So the number of pineapples is 12. I want 10 to be ripe. That's my success. The probability of it being ripe is 90%. To the success, so this would be the probability of it not being ripe would be what? 0.1. And how many would that be, Ryan? To what power? 10, no, 0.1?
Oh, 10 minus 10. Oh, 2.
2, because it has to add up to 12. Okay, now I have 11 ripe, so I want 11 successful pineapples. So you have 0.9, and this would be to the 11, and this would be 0.1 William Doe to what? 1. Excellent. And here I'd have the probability of all 12 being right. And you would figure that out. Do I need to go any further? You get to use your calculator. And I don't know why I'm putting P here, because I'm thinking pineapple. It should be combination and probability. So you're taking 12 factorial over 10 factorial, 2 factorial. So just to remind you, you have to go 12 times 11, this cancels. 2 times 1, you get 66. You get to use your calculator. You would take the sum of those. Thumbs up if you got it. Now, listen to question 17. It says that the probability no more than 9 are right. No more than 9 are right. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I found the probability, and this, after you work it all out, is 0.8891. Do I really want to go through and find the probability of all of those and put 1, 2, 3, 4, 5, 6, 7, 8, 9? This is why I did this one. Will, what would be a shortcut?
1 minus 7.
Very good. 1 minus your answer to number 16. And you would get 0.1109. Get out of town with that one. James, did you hear that? Because I saw you do all the 1 through 9. You could have just taken it and subtracted from that. That is called a complement. And if you looked at your definition of a binomial distribution, it said that these two should add up to 1. Okay? Okay, good for us. Okay, now questions on the worksheet. On page 4. Any questions on that? Alexander. Number 6. Okay. We're doing great, guys. But be ready for... This is interesting. Okay. Page 4. You said number 6. Aha! Okay, this is making sure, Alexander, that you understand what factorial means. What does the factorial mean in math? All the numbers below it. And what is the pattern when they're going down? When they're decreasing? Are they going down by 2? Or are they going down by 3? What are they going down by? By 1. Okay, good. So, if this is telling you the first term is n plus 1, what would be the next term? N. Very good. What would be the next one? Very good. N minus 1. And the next one? Beautiful. And it's going to go all the way down to, and what's my last number going to be? Uno. It's going to go down to 1. So here, on this one, you're going to use the same principle. It's going to start with n minus 1. Psi, what would be the next number? What would it be next? And that would be going up. I'd be adding 1. What do? You subtract 1.
So n minus 2.
There you go. What would be the next one?
It's n minus 3.
And what does it go down to?
N minus 1.
1. And I don't know why I'm not putting a plus sign in here. Okay, so what could I cancel here? I could cancel all this way down to here, right? Actually, no, it's not a plus, it's times. What am I thinking of? Okay, so you're multiplying and you cancel all the way down, so you're just going to get down to m plus 1 times n. Okay? Any other questions on any of these? 16. Okay, middle term. How many terms in if it's to the 6th power? No. 7. So what's the middle term? 4. Okay, let's keep going with this. So I'm trying to find the 4th term. So this will be 6. What will this be, Zin? 3. It's always 1 less than the nth term you're finding. And you'd have 2x, and you'd have negative 2. Now, how do I know What should I put as an exponents? And so what would this be? 3. And then you have to figure it out. This would be 6 factorial over 3 factorial, 3 factorial. So you have 6 times 5 times 4. This cancels. So this would be 20, 8x cubed times negative 8. And so 160 times 8 is what? Why can't I think today? 8, and it would be negative x cubed. Yeah. Okay. Okay? Okay, how about in the book work? Anything else on those two? Yes. Yeah?
Why would it, why would it be like 2 instead of 3, because isn't it n minus 1?
So,
It's like 4.
okay, but you're looking for the fourth term, right? How many terms are there? There's 7 terms, so the middle term would be 4. Remember, there's always one more term than the exponent in the expansion. Everybody have that? Anna, do you have that?
Yeah.
Good. Okay, so let's go for it. Let's go for the lesson. So, turn to page... Okay, you guys, if you're being naughty and not paying attention, you better pay attention now. Okay. Turn to page 10. And I'm hoping to get to some of your homework. Where's my load dock? Okay. Okay. On the page before that, you have the sample space. If you look at page 8, ooh boy, that's not very focused. Let me try to focus that. Okay. Okay, on page 8, you're going to be using this to help you with this lesson. This is the probability of 2 dice with 2 different colors. I'm letting the red be the first die, so red, and then white. So these are the pairs when you roll the 2 dice and how they can land. And so how many combinations or ways could it be in that sample space there? How many do I have? 36. And how would I get 36 for you? 6 times 6. So you have 36 ways. So when we get to it, we're going to be referring to this. But the sample space of 36 is, or of 2 dice is 36. Okay? So now, don't get confused with what we've done previously. We have done conditional permutations, where it has to be an odd number, or it has to begin with a vowel, or we might just have 8 digits and we're only going to use 4 of them and they can repeat. Those are conditional permutations. This is conditional probability. 2 different things, sound alike. Okay, a conditional probability contains a condition that may limit the sample space for an event. This is key. 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 Got it, Anna? I don't know what you're doing over there, but put it away. Okay? Are you writing down? You're in your little journal or something. Okay. So, the symbolism to show that it's a conditional probability is a slash mark. And I don't know why it came out like that. It's the probability of B, and this word is given that. A has already occurred. So when I say that, James, what would be the first event that happens? A. Very, very good. This is my first event. And by my first event happening, it has limited the sample space. It's not the big general thing. All of a sudden I'm looking at another select view and I'm picking the second event. The second event is happening from that. Okay? So on here, a drawer has 5 red socks and 7 blue socks. This is a simple probability. I'm going back to something you already know. If I want you to find the probability of choosing a red sock, Matt, what would be your answer? Right here, find the probability of choosing a red sock. Who knows? Cy. 5/12. It's 5 out of 12. I think you need to correct something that you're doing right now. Thank you. Find the probability of choosing another red sock if you don't replace the first sock. Borna, what would that be? 4/12. I didn't replace it, so do I still have 12 in there? Read it again. B. Find the probability of choosing another red sock if I didn't replace the first sock. 4/11. I didn't replace it. I already chose a red sock. Okay, so it's 4/11, correct? There's only 12 socks left in there. So find the probability of choosing 2 red socks. So I'm doing a red and a red. So you will have 5/12 times 4/11. Why is it and? It's because it's consecutive events, and you're going to multiply them together. I want to see no decimal as an answer. Answer has to be reduced fraction. Billy, what does it have? The answer have to be in?
Fraction.
Thank you, Tyler. Reduced fraction. So you have 5/33. I'm getting annoyed with some of you. Okay, so now we're going to go to some of the conditional probability. Okay, why do I know that? Because of this silly looking slash mark. Okay, now I am going to be rolling 2 dice here. So I have a red one, and the red one is marked like this, and I have a white one. Okay, I'm going to make sure it's in the screen here. Okay, I know it's yellow, but I don't have a red one. I put red on there. So it's supposed to look like red, but it doesn't very well. Okay, so on here, if it's saying I have a white one that's 5. So the white is 5 right here, correct? Now the red one could be what? This is my first event, remember, because this is a given that. This is the first event. This is where I'm going to start. And it's going to limit the sample space. I'm not talking about 36 anymore. Choices. I'm talking about when the white is 5. So the white is 5. What could the red be? It could be anything, right? It could be a 5, 6, 3, 1, or 2. So it has 6 choices, right? So, in other words, I'm going to list these right now. This could be a 1-5, a 2-5, a 3-5, a 4-5, a 5-5, and a 6-5. Notice I go red, white. I just do alphabetical when I'm listing them. I'm not looking now at the probability out of 36. I'm looking at the probability out of these 6. How many have a sum of 8 or 11? Here's one, and here's one. So my answer is 2 out of 6, and you would get 1/3. Okay, let's go to the next thing, B. Okay, what is my first event, Max? I disagree. Look back up here. What's my first event? Because how I read this, listen to how I'm reading it. The probability of the sum is 8, given that the R is 3. So what happens first? The given that. Okay, so what are my choices? I don't think I have to show you with the dice again. It would be a 3 for the red. The red always has to be a 3, but the white can be 1 through 6. So 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. How many have a sum of 8? 1 out of 6. Billy, come on. You can't do that to me on this section. Get your pencil out and write. You're falling asleep. Okay, but you're just sitting there falling asleep on me. You gotta get to bed earlier. Okay, on here, what does or mean? This is a hard lesson, so you need to focus, you guys. Believe me. Okay, or means to add or multiply. Add. So you have to decide, is the probability of the sum 6 plus the probability of the sum 8? This is what we did 2 days ago. Is this mutually exclusive? Is there anything that overlaps? Can you have 2 dice be the sum of 6 and 8? No. So obviously you just add them up. Now what you can do is sum of 6. That would be a 1, 5, a 2, 4, a 3, 3, a 4, 2, and a 5, 1. Now in this, you got to get everything straight in your head. This isn't a given that. This is not a conditional probability. So what's my sample space out of when I'm talking about 2 dice? 12? 36. Not 6 times 2, 6 times 6. It's 36. I just showed you all of them. There's 36 little things in here, 6 by 6. So here I have 5 out of 36. Sum of 8. Can I have a 1 and 7? No, because there aren't 7 sides to a die, right? So I would have a 2, 6, a 3, 5, a 4, 4, a 5, 3, and a 6, 2. You'd have 5 out of 36, and you get 10 out of 36, which is 5/18. Okay, right here, remember, or if they're mutually exclusive, you add them. If they are not mutually exclusive, you have to subtract the overlap, and we're going to get there now. Yes? Why can't we have 7? There's not a 7 on a die. Okay. Now, this is where this sheet comes in handy. So I'm sorry with the note taker. There's also more of these on Blackboard under course documents if you have to, if you want to print them out. Okay, so this, everyone watch. Okay. Bring this kind of up if you can, and keep this like here so that you have that to work from. I'm not going to bring mine up like that because I have one right here. I'm going to cover this. I know what I'm doing. Hold on. Hold on to your hats. Okay, guys. On here. Okay, so you're going to say, what's so big about this? Okay, because you're going to see how I teach it, and it's kind of different, but it helps when we get into harder problems. And we know means to multiply, right? I'm finding the probability when the red equals 3 times the probability when the white is greater than 4. Now, on here, if you look at this, and I'm going to first show you on here, this is my red, this is my white. The red equaling 3 would be right here. Actually, this is the red, and this is the white. Sorry. Okay, so I have a 1 by 6, correct? Okay. Now here, the white is the second one, is greater than 4. So what can the white be? 5 and 6. So it's the last 2 rows. Whoopsie. Yeah. You said columns and you almost threw me there. Okay. So you have a 6 by 2. Everybody follow that? Here, I'll put the 6 down here. Where's the overlap? Right in this. Now, what I want you to do here with the red and white, this is like here is your red, here is your white of the first case. The red by white, the red only has one choice. Abraham, please listen. What are you doing?
Finding my worksheet.
Huh?
Finding my worksheet.
Why? We aren't in the worksheet.
No.
This was the page before. Ay, 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 ay. Okay, so on here, the red only has one choice while the white has 6, right? That made up all of these choices. So I would have 6 out of 36. I'm using this whole big box. Now over here, if I draw the 2 blanks, the red, notice the red could be 1, 2, 3, 4, 5, 6. It didn't have any restrictions on that. The red could be anything, but the white had to be greater than 4, so it only had 2 choices. It was 2. Notice it is a 6 by 2. This was a 1 by 6. So you would multiply this. So you can reduce this to 1/6 times 1/3, and you would get 1/18 is your answer. Now, check out the next one. You're going to see something goofy happen. Or means to what? Add. I'm going to have the red and the white of the first situation. Probability of R less than or equal to 3. So how many choices does the red die have on that part? What can the red be, Layla? It can be 3. Can it be anything else? It has 3 options. Thank you. It has a 1, 2, or 3. If you would look at that on here, it would be 1, 2, or 3. It would be this right here. So it has 3 options. The what could be anything. So you have 18 over 36. Okay, the white is less than 5. Do I have anything, restrictions on the red for this probability? The red can be what? Farid, what can it be? It can be anything, so how many choices? 6. The red can be 1, 2, 3, 4, 5, 6. The white has to be less than 5, so it can be 1, 2, 3, 4. So you have 4. Hold on to your hats. I'm adding here. I'm going to draw my box so you see it. The white has to be 4, 5, or 4, 3, 2, 1. So it goes right here. Notice that is a 6 by 4. That's where you got the 2 numbers. Now, we're adding. Are those mutually exclusive? No. Don't we have overlap? And what is the overlap? 3 by 4. So I'm going to subtract a 3 by 4. Where do you think you get that? Right here, if you aren't using the box. It's these 2 probabilities. You're just taking the red and the white. And you will be subtracting the 12 out of 36. And when you get that, you would get 30 out of 36, which is 5, 6. I don't want you always to have to use this visual. So I want you to know where you're getting all of these. Okay? So on here, so all of these are, here's the red, it has to be 1, 2, 3, the white can be anything. Here, the red can be anything, the white has to be 1, 2, 3, 4, and then you multiply the 3 times 4 and you subtract it, the A and B. Now here, what kind of a probability is this one? This is a, Karen, what is it? Conditional. And what is the first thing that happens? The 8. So all of a sudden, What are my possibilities of the sun being 8? Who's ya?
2 plus 6, 4 plus 4, 3 plus 5, 5 plus 3, 6 plus 4.
What I do, I just go in the order there so I don't miss any. Okay, otherwise you might miss them. So how many choices do I have? All of a sudden, remember, it's changed the sample space. I'm not looking at this 36 anymore. I'm just looking at these. Remember, conditional probability limits the sample space. So it limited to this, which is 6. And how many have the R less than 6? 1, 2, 3, 4. 4 out of 6, which is 2/3. Okie dokie from Miss Skokie? Okay, now, let's go over here. Suppose you, you thought you were done. Suppose you draw 2 marbles out of a bag that can, and then we're going to start with the homework. Consists of 5 yellow, 4 red, 3 blue marbles. If the drawing is without replacement, that means you don't put it back. Find the probability, find the indicated probability. So what is my first event here, Shivani? What happens first?
Blue.
Thank you, Max. This is the first event. So I want to draw, a blue one is drawn. I want to find the probability that I am going to draw a yellow one. How many yellows are left? 5. And how many marbles are left in the jar? 4. How many marbles were in the jar? There were 12 marbles. 11. You're done. This is very similar to where we began here. A conditional probability is finding the probability of the second event. And something happened in the first event that changed your sample space. Here I picked a red sock. So it changed my sample space. Instead of 12 socks, I have 11 socks. Here I chose a marble. So instead of 12 marbles, I now have 11 marbles. Pardon? Oh, now you can see it? Okay. Okay, B. What's my first event? Obviously red. So, Armin, what would be the probability of choosing another red marble?
3 out of 11.
Very good. Why? Because there's only 4 red. You picked a red, so there's 3 left, and out of 11 because there's 11 marbles left. Okay, Hayato, what's the first event? Red. So what's the probability of picking a blue?
Zero.
12? Didn't you pick a marble that didn't? 11. And why is it 11, Hayato? Okay, red was taken out, so 1 was already removed. Okay, both marbles are blue. Is this a given that? Psychondra, is that a given that?
Yes.
What are you trying to find the probability of?
Blue.
Blue. Am I just trying to find the probability of the second one being blue? That's what a given. You want a blue and a blue. So it's multiplied. See the difference. So what would that be? This would be
3 or 1/4 times 2 is 11.
okay, where am I? Okay, 1/4 you got, okay, you went really fast for me. That's 3 out of 12, and then what?
2 11.
2 11ths. And then he reduced this to 1/4. And then you could reduce this, and so your answer is 2. Ooh, Cheryl Barrow. 1/2. So you get 1/22. Wow, Cheryl. Okay, now cards. Who doesn't know anything about cards? Be honest. Okay. I'm going to kind of write this out. How many suits are there in cards?
4.
There are 4 suits. There's 52 cards. So each suit has 13 cards in it. And you have the suits are clubs, spades. There's 13 spades. There's 13 hearts. And there's 13 diamonds. These are black. So you have 26. And these are red cards. And the numbers on the cards are 2 through 9, and then you have a jack, queen, king, and ace. Ace can be 1 or 11 depending on your, oh, thank you, 10. Okay, these are called face cards because they have a face on them. I'll bring my cards on Monday. I forgot them.
I have.
You have some in your, okay. Hold on, I'll borrow them in a second. So now, on this one, both are diamonds. What kind of probability would that be of team? Is that given that, an and or an or? It's an and. It's just like this one. So I want the probability of a diamond and a diamond. Now we're drawing them without replacement. I'm going to make a point here for a second. Okay, so how many diamonds do I have, Andrea? 13 out of? And then what would be my second diamond? 12 out of 51. Why 51? Thank you, whoever said that. Max, you're speaking out of turn. So this would be 1 over 4. This goes into 12 3 times. And 3 over 51 can reduce to 1/17. Get out of town. I think I did that right. Yes, I did. Okay. Okay. Now, this is a given that. Tyler, what's the first event?
I'm not sure.
How dare you? Murdoch. 4. Why is it 4? You're right. But why is it 4? You don't know. Somebody told you? Who can tell me why it's 4? Nobody. If there's a slash. What does a slash mean? Given that. Yay, Borna! You win a prize. So, given that, this is a conditional probability. This is the first event. If you didn't learn that, you didn't learn the lesson. So that limits, we aren't talking about 52 cards anymore. We're only talking about 4s. And how many 4s are there in a deck of cards? 4. You have a 4 of clubs. You have a 4 of spades. You have a 4 of hearts. And you have a 4 of diamonds. So how many of those are a club? 1. So it's 1 out of 4. Tyler, back at you. What's the first event?
Different parts.
Yes.
Okay.
How many hearts are there?
There's
13 hearts. How many of them are 4?
1.
1. There you go. A given that probability changes your sample space. I'm not talking about 36 or 52 anymore. I'm just talking about the hearts. Yes.
Wait, for B, is it like the probability that you draw 4 and that 4 is a club, or that you draw 4 and then you draw a club after?
Out of those 4s. Okay? This limits your sample space. So now I'm just have the 4 cards of the 4s. Okay? So here, Armand, let's take this one. What's my first event?
It's black,
And how many black cards do I have?
26,
And how many of those would be 7s?
2,
2, because you have, and that can reduce, you have club, a 7 of clubs that's black, and a 7 of spades that's black. Okay? On this one, Sarah, what's my first event? Diamond, and how many diamonds? And how many aces? Okay, good. How many cards are red? Ashley, how many are red? And how many of those are spades? 0. Hot dog. Okay, so now take out your, we're going to start doing your homework. Nothing better than that. So turn to page 3. I don't think I'm going to get to the warm-up. What do you think? You know what? I'm not going to. Okay. I am. I'm going to make it even. That's what I had up there. I was going to do the odds in class, but we might add on Monday's assignment. That'll be good. Okay, let's go to even. Let's do this. And I'm going to come around and stamp it. That was my original homework that's on the, let's just do evens. And we aren't going to start. You guys struggle through that. I think you'll be able to do that. Now, on here, I just want to note, this, I wrote the word given that out. Don't know why, but that's the same thing as a slash mark. Okay? You can use this. And like I said, there's more on Blackboard if you need to print it out. It's in your packet. Okay, so let's do these. And I'm going to have you put them up on the board. And I'm going to come around and stamp the people's homework that I didn't get earlier. Oh, here it is. Okay, here I come. I know there's a few of you back here, right? Bye. Okay. Anything else? My late birds. I'll be right back. I don't know, you were naughty. Really. You were so naughty. Now that you don't have enough.
What are you talking about?
What do you think?
Oh, you took it.
No, you didn't.
No, I didn't.
Oh, what?
Okay, yeah, do it again. Do it again.
Like, that is still getting homework thing?
No, it's not done. You just have your answers. There's a lot of-
This is like,
Yeah.
I didn't bring them, but it wasn't.
No, honey, you just did it now. You would remember doing it. Were you here yesterday? You were late. Okay. Number 1A, Max, you put up B, Psychondra 2, B. You put up A, Psychondra B. Number 2, who wants to put this up? Ashley. And number 3, Daniel. I haven't called on you. You can use this other board on the right side. And Daniel, you get to put up number 3. At least set it up. Team, you go put it up.
Daniel, can you just get after
And you didn't
and then there's that stuff. All Zoom, all Zoom has it.
Can you hear the
Is that obvious?
It's not fun, it's not fun.
I don't think I turned off the video.